Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 8.5, Surface Areas of Pyramids and Cones for my Course 3 class. Our objective is to find surface areas of pyramids and cones using nets and formulas. Okay, mostly in this section these notes will focus on using the formulas. We will do some work with nets in class as well, and maybe a little bit combining the two a bit as well. Okay, so first of all, we'll start with some vocab and key concepts. Lateral area and surface area of square pyramids and cones. The lateral area of a square pyramid is 4 times the area of one of the lateral faces. And one of the lateral faces would be any one of those triangles. Okay, if you look at the sketch over here, you see this little L, this cursive L. And that is the lateral height. In other words, the height of that face, not the height of the pyramid. So you want to be very careful about that. So here we go. So lateral area is going to be 4 times 1/2 times the length of one side of the base, so little b, or this length of the triangle, times L. Okay, which then translates to 2BL. Because the 1/2 times 4 is 2 times the base, the length of the base of the triangular face, and then the lateral height. The surface area of a square pyramid is the sum of the lateral area and the area of the base. So just B. In this case, it would be the side squared, okay, whatever, because it's a square. So that's that. The lateral area of a cone is 1/2 the product of the circumference and the base, and the slant height. So this is very similar. This is somewhat, we've talked in class how that sort of resembles sometimes a triangle, but it's really a portion of a circle. So again, this is going to be 1/2 times the product of the circumference. Remember, the circumference is 2 pi r, okay, times L, the slant height, okay, or simplified to 2 pi r L. Okay, so surface area again is the lateral area plus the area of the base. Slant height, or lateral height as I called it, but slant height is really the better term. That's the one that your book uses, is the height of a lateral face, hence the L, of a pyramid or cone. Okay. All right, so that's, again, we're focusing in these notes on using the formulas. We will look at doing with nets in class. Okay, so finding surface area. In order to buy paint to cover the inside of the roof and the floor of this playhouse, the formula for surface area of a square pyramid, use the formula for the surface area of a square pyramid to find the area. Okay, so basically what that's saying is we're going to figure out the surface area of the roof plus the surface area of the floor. If I took out these lateral faces right here, okay, that's what I would end up with then, is a square pyramid. Okay, so again, the formula for that is going to be 2 times the base times the lateral height plus the area of the base. And for that, we can substitute S squared, or B squared in this case. We'll do B. You can use S squared. It's kind of your discretion how you want to do that, but anyway. Okay, so I'm going to substitute in 6 for B. Okay, so this would be B. and 3.5 for L. So remember, this would be 6 or B, and this would be 6 as well. Okay? So it's going to be 2 times 6 times 3.5. So that's the base times the height. There are 4 of them, but then we take half of it, so that's where we get the 2. Plus B squared, or 6 squared. That's just substituting in my information. So when I simplify this, I get 42. 2 times 6 times 3.5 is 42. 6 squared is 36. When I add together, I get 78. So the surface area of the roof, the inside of the roof and the floor, gives me 78 square feet that need to be painted. All right. Okay, let's go to the next one. Find the surface area of a cone with a radius of 9, a slant height of 15 feet, to the nearest square foot. Okay. So when I substitute in, this is going to be pi RL times plus pi times the radius squared, because remember the base is a circle. So the area of a circle is pi r squared. Okay, when I substitute in my numbers, this is going to be pi times the radius of 9 and the slant height of 15 plus pi times radius squared, so that's going to be 9 squared. So we're substituting in 9 for radius, 15 for slant height again. Okay, and I must confess I do not have all of this worked out, so I'm going to do it real quickly here. And they have it broken into pieces like this. We did talk in class some about how you might do it a little bit differently, which is fine. So I'm going to do pi times 9 times 15. And this is 424. I'm going to do to the nearest tenth right now, and then in the end I'll round to the nearest foot. Okay? And pi r squared, so 9 squared times pi is 254.5. Okay? So I will then add 424.1 plus 254.5 and get 678.6. So 678 actually 0.6 would round then to, 679 square feet. Now, you could have also done this, and I'll do it real briefly. Remember, you could also simplify this right here to be pi times, 9 times 15, which is 135, plus 9 squared, which is 81, which equals 216. And you get 678.6 rounded. Okay, so that's about 679 square feet. Again, I'll review with you how you can do this using the order of operations, multiplying first and then doing that. Here, I just did each section. So, again, 2 different ways to do it. All right, you have a couple of quick checks here. If you would please do those. We have the surface area of the Great Pyramid is shown at the right. Okay, this would be a square pyramid, all right? And then the surface area of the cone at the right. This has a slant height of 5, a diameter of 8. Here, this is a base length of 755 feet and a slant height of 611 feet, just in case. Oh, and you can't even see where I'm pointing. I have to get used to the new frame on this. My apologies. Okay, see you in class soon. Bye now.